So, hello, very good evening to all. I hope my voice is audible to all of you, right? So, I am just launching a quick poll here. Everyone, जल्दी से बताओ. Responses? Yeah, right. Very good. Good. Right. Good. So basically, today we are going to see electrochemistry chapter, right? So in this, we are going to see some important questions from this chapter, that is electrochemistry, and we are going to solve all important questions either from the numerical section or theoretical section of electrochemistry, right? In this, basically, I'm including both JEE and NEET questions for your better understanding. So this is going to be a very important session for all of you. In previous class as well, we already solved solution PYQ questions. In this class, we are going to solve electrochemistry question. So I hope yes. So everyone, yes, तो poll सबने fill कर दिया है. So now I am ending this poll. Good. Now, let's start with the class beta. So, first of all, in quickly, we're just going to see some important formulas for electrochemistry. So, first 5 to 10 minutes, we are going to see some important formula of this chapter, right? So, first of all, we all know what is electrochemical cell. Can anyone tell me? Electrochemical cell basically which converts the chemical energy into electrical energy. तो पहले फटाफट जो important formulas है ना उसको देखते हैं. Then we are going to solve numerical related to this particular formula, right? So basically in electrochemical cell, what happened key gives energy of the spontaneous redox reaction is converted into electrical energy. So this is one of the major important formula which we need to remember, that delta G is equal to minus NFE. What is N here beta? N is the number of electrons. F is the Faraday constant which value is equal to 96,500 coulomb. And what is E? That is EMF of the cell, right? So this delta G comes out to be minus NFE. ठीक है? Everyone clear है ये सब कुछ? N is the number of moles of electrons, F is the Faraday constant, and E is the standard cell potential. Now, the Nernst equation also play a very important role. What is the application of this Nernst equation? With the help of the Nernst equation, we can easily calculate the EMF of the cell, equilibrium constant. So these all are the applications of Nernst equation, that why we study Nernst equation. So basically this equation which represent the dependence of single electrode potential. ठीक है, उसी को हम क्या बोलेंगे? Nernst equation. So what is the formula for calculating Nernst equation? That is E is equal to E naught minus RT divided by NF ln concentration of product divided by concentration of reactant. On further, we can also write as EMF of the cell is equal to standard EMF of the cell minus 0.0591 divided by N, and this is nothing but log concentration of product divided by concentration of reactant. So how will you obtain this formula? Basically, when we put the value of R, put the value of T, that is 298 Kelvin, and F, that is 96,500. And also we know when we have to convert ln into log, what we need to multiply? We need to multiply by 2.303. So when we multiply by 2.303, then natural log is converted into log base 10. So by putting all this constant, either T, R, F or ln values, 2.303, we can easily get this formula. So this formula is very useful for us to find the EMF of the cell, that is E naught minus 0.0591 divided by N log P by R. Everyone clear है सबको? एक बार confirm करो सभी. Is this clear to everyone? Right? Nernst equation. Clear? Done? Everyone, please reply, quick responses though. Is this clear to everyone or not? Yeah, yes, clear. Very good, beta, right? So that is the formula for calculating the Nernst equation. Now let's see the next thing. The next is conductance of electrolytic solution. देखो यहाँ पे हम लोग क्या कर रहे हैं, बेसिकली वी आर जस्ट लुकिंग एट द फॉर्मूला बिकॉज इन दिस वी आर गोइंग टू सी मोर एंड मोर क्वेश्चन सेशन, राइट? इन दिस वी आर गोइंग टू सॉल्व मेनी क्वेश्चन एज वी कैन डू. सो हम थ्योरेटिकली बहुत मेन मेन जो फॉर्मुलेज है बस उनको ही हम कर रहे हैं, नॉट इन डिटेल वन, राइट? नाउ if I'm talking about the conductance of electrolytic solution, so we all know that there are four important terms in conductance of electrolytic solution. The first is resistance. The second one is specific resistance, also known as resistivity. The third one is conductance, and the fourth one is specific conductance. That is specific conductance means कैसे निकालोगे आपको conductivity we can say, right? So resistance, specific resistance, conductance and specific conductance also known as conductivity. So let's quickly see the formula for all this so that we can easily remember. Now what is resistance? Everyone know that is it offer the restriction in the flow of current, right? That is called resistance. Now how can you represent this resistance? So resistance is reciprocal of conductance, right? So or we can say that कि रेजिस्टेंस को हम कैसे रिप्रेजेंट कर सकते हैं, सबको पता है फॉर्मूला R इज इक्वल टू रो एल बाई ए. दैट इज R is directly proportional to the length of the conductor and inversely proportional to the area, and proportionally constant यहाँ पे क्या लगेगा बेटा, that is rho, that is a specific resistance. So we can say that R comes out to be RL by A, rho L by A. And this is very important formula that you need to remember. ये formula जरूर याद रखना because सिर्फ इसी फॉर्मूले की हेल्प से we can easily find many question solution, right? So this formula is very important. That is R is equal to rho into L by A. From this formula itself, we can also derive the value of rho. What is rho? Rho comes out to be R into A divided by L. So this is the formula of rho. So the formula of a specific resistance, or we say resistivity, also derived by using this formula only. That is R rho is equal to R into A by L. Is this clear to everyone? Resistance? Chalo. Now, the second is specific resistance. So the specific resistance is denoted by rho, right? And its value is already calculated. That is rho is equal to R into A by L. And units of resistivity is, that is ohm meter, or we say ohm centimeter. Now, the next is conductivity. So it is also a very, very important word, that is conductivity. As the name suggests, conductivity, right? So conductivity is the reciprocal of nothing but resistivity. So conductivity is the reciprocal of resistivity. So we know the formula of conductivity. How will you derive this? बताओ जल्दी. So we know that rho is equal to R into A by L, right? So this is the formula of resistivity. So we can say conductivity is equal to 1 upon rho. So 1 upon rho means what, beta? That is L divided by R into A. So this is the formula for conductivity. 1 upon R we all know. 1 upon resistance is known as conductance. So this comes out to be G into L by A. So this is the formula for calculating the conductivity. I hope this is clear to everyone. सबको clear है? Confirm करो everyone. Clear हो गया सबको? Right? So this is the formula for calculating the conductivity. Good beta, right? So this is how we can actually calculate the conductivity. Now, what is L by A? Can anyone tell me what is L by A? L by A को क्या बोलते हैं? एक specific term होता है. One particular specific term for this L by A ratio. What is this term known as? L by A term को क्या बोलते हैं? बताओ फटाफट. क्या बोलेंगे इसको? दैट इज गुड, दैट इज सेल कांस्टेंट. क्या बोलने वाले हम इसको? cell constant. So this L by A is known as cell constant. तो फॉर्मूला क्या आ गया? K is equal to G into G star. G star is represented as cell constant, right? Chalo, very good. Now let's see the next thing, that is conductance. So it's a very simple thing, conductance, that is the reciprocal of resistance is known as conductance. So we can say that G is equal to 1 by R. We already know the value of R, so just put this value, right? So this is how we can obtain the expression for all these three things. Now, this is a very important graph, we can say. This graph we draw between the molar conductivity and the concentration, right? Molar conductivity and the concentration. So this is for a strong light, and for weak electrolyte, we obtain the graph like this. Okay? This is for the weak electrolyte. Okay? Now, this is for strong electrolyte and this is for weak electrolyte, right? So as we see, as the dilution increase, how can we say that dilution increase beta? In x axis we have a concentration. तो अगर आप इधर जाओगे तो क्या increase होगा? Concentration. Just opposite, इसका उल्टा सोचो कि अगर आप इधर जाओगे तो क्या increase होगा? Dilution, right? When you move backward, then dilution increase. Obviously, because we move from राइट टू लेफ्ट टू राइट, राइट लेफ्ट टू राइट बढ़ने पे क्या हो रहा है? कंसंट्रेशन. तो उसको उल्टा सोचो, व्हेन यू मूव फ्रॉम राइट टू लेफ्ट इन द एक्स एक्सिस, क्या इंक्रीज होगा? दैट इज डाइल्यूशन. सो अपॉन डाइल्यूशन मोलर कंडक्टिविटी इज इंक्रीजेस, राइट? सो मोलर कंडक्टिविटी डाइल्यूशन करने पे इंक्रीज होता है. एंड दिस स्ट्रेट कर्व इज फॉर स्ट्रॉन्ग इलेक्ट्रोलाइट, और ये जो ऐसे कर्व बना है शेप में, वो किसके लिए होता है? वीक इलेक्ट्रोलाइट के लिए. So this thing we need to remember, right? Now, so for the strong electrolyte, molar conductivity increase slowly with the dilution and can be given as cap m cap naught m minus a under root c, where the value of a for the given solvent and temperature depends upon the type of electrolyte, that is the number of ions produced by the dissociation of electrolyte. So this formula is very important and this is valid only for the strong electrolyte. Remember this thing better, right? Now, in the electrolytic cell, we are going to study Faraday laws. So we have only two Faraday laws. Sir, please slow. Okay, beta. Basically, our main purpose is to solve questions. So I'm just quickly go through all these formulas and all these things so that we can solve more and more questions, right? Now, chalo, dekho. So electrolytic cells and electrolysis. So what is the Faraday laws? In electrolytics, we mainly deal with the Faraday laws. So what is this Faraday law? So Faraday, we have two laws for the Faraday. According to the first law of Faraday, it states that the mass of a substance deposited or liberated is directly proportional to the quantity of electricity you would apply, right? मतलब जितना मास डिपॉजिट होगा या लिबरेट होगा, वो इस बात पे डिपेंड करेगा कि कितना क्वांटिटी ऑफ इलेक्ट्रिसिटी आपने वहां पे दिया है. दैट वी कैन से दैट mass is directly proportional to q. Now here we have प्रोपोर्शनली कांस्टेंट. कैसे लिख सकते हैं? देखो, कई जगह m को w से भी रिप्रेजेंट करते हैं, दैट इज w इज डायरेक्टली प्रोपोर्शनल टू q. प्रोपोर्शनली कांस्टेंट हियर इज zq. समवन z भी लिखते हैं, कई लोग e भी लिखते हैं, तो इट डिपेंड्स, राइट? मोस्टली इन बुक्स z इज रिटन, राइट? सो w इज इक्वल टू zq. नाउ वी ऑल नो what is the formula for Q? How will you write charge beta? We can write charge as I into T, that is current into I, current into time, right? So we can write as I into T, I into T. So the formula comes out to be W is equal to ZIT. What is this Z? So Z is electrochemical equivalent, and we can find the value of Z by simply molecular mass divided by NF. If we know these three things, molecular mass divided by NF, we can easily calculate the value of Z. So this is how we'll calculate the value of Z. I hope this is clear to everyone. What is Faraday's first law? What is the formula? And how will you calculate Z for the particular question? Right? I and T is already given, either given or they ask to calculate the value for this. Right? And every time you need to calculate Z by using this formula, that is molecular mass divided by N. So please confirm. Is this clear to everyone? Yes. Confirm करो. Clear है? Can we go ahead? चलो. ठीक है. So we already write this formula. So move to the next. Now let's we are going to solve the previous year questions, right? So let's solve some previous year questions related to this electrochemistry chapters, right? Let's start with the first question, beta. So the first question is, that is, the standard cell potential of the following cell, that is Z into Zn2 plus Fe to Fe, is 0.32 volt. Calculate the standard gives free energy, right? Calculate the standard gives energy change for the reaction. So anyone, प्लीज टेल. ये 2024 में क्वेश्चन आया लास्ट ईयर ही, इसी साल 2024 नीट का क्वेश्चन है ये. नीट 2024. So they're asking, calculate the Gibbs energy change for the reaction, right? So how will you calculate? Can anyone tell me the formula? First of all, we know delta G is equal to, what is the delta G? Standard बोला है ना, so delta G naught is equal to minus N F, and here also E standard, right? Now what is N in this question? Number of electrons. देखो, जिंक से Zn+2 दो इलेक्ट्रॉन, Fe2 से Fe दो इलेक्ट्रॉन, so the number of electron is 2. कितना आया? Number of electron 2 आया. Wait a second बेटा. हाँ, so number of electron is 2. Here also 2 electrons. So minus n की जगह आ गया 2. What's Faraday constant? So it is already written that Faraday constant is 6480. So this Faraday constant 96,000 is 0.32 volt. So it is 0.32 volt. So putting all this value, what you get negative तो रहेगी 61,751. That is 61,751.68 joule per mole, right? But in this question, all the values are given in kilojoule. So for kilojoule, just divide by 1,000. So values comes out to be, बताओ कितना आया? That is minus 61.751 kilojoule per mole. So which of the following is correct out of this four options? फटाफट बताओ, which option is correct बेटा? Which option is correct? Option A, right? Good. Option A, very good बेटा. So option A is absolutely correct. Now next question है, आप सभी लोग ट्राई करो सॉल्व करने का. Then I'm going to solve this, right? क्या पूछा है? I'll just explain. In this we have a two list, list 1 and list 2. So in list 1, statement is given like 1 mole of H2O2 O2, 1 mole of MnO4 2Mn plus 2, 1.5 mole of calcium from molten CaCl2, and 1 mole of Fe2O3. How many Faraday is required for this conversion? So just calculate the number of electrons that actually participate, and on the basis of you can actually find the number of Faraday required. ठीक है? तो चलो, I'll explain this also. So for the 1 mole of H2, right? So 1 mole of H2, how it decomposes to form O2, right? So basically, here we have H2O. So we all know that H2O decompose, that is when the two H2O decompose, it will give O2 plus 4H plus and this 4 electrons. So how many electrons they are giving? 4 electrons. So the answer comes out to be how many F it required in terms of Faraday, right? So A का कितना हो जाएगा भाई? A का बताओ. So basically each mole of O2, ध्यान से समझना, each mole of O2 require the transfer of 4 moles of electron. So each mole of O2 को कितना electrons का transfer चाहिए? 4 moles of electron. Therefore, to produce the 1 mole of O2, right? 1 mole of O2, you need 4 Faraday of charge. कितना चार्ज चाहिए होगा? 4 Faraday of charge. But यहाँ पे एक twist है, वो देखो, 4 Faraday of charge. However, since the reaction shown in the table suggests that production of only 1 mole, ठीक है, because here we calculate for the 2 mole H2O ना, so for 2 mole if the 4 F charge is required, then for 1 mole 2F is required. ठीक है, तो कितना आ गया? 2F is required. Now, for the second case, that is MnO4 negative 2 Mn plus 2. So here the oxidation number of Mn कितना आएगा बताओ? That is X minus 8 is equal to minus 1, because oxidation state of oxygen is minus 2. So minus 2 into 4, minus 8. So X comes out to be minus 1 plus 8, that is 7. So here we have a plus 7 and here we have a plus 2. So how many electrons transfer will takes place? That is 5. Kitna? 5. So the correct answer is 5F. So for this, 1 mole of option ए बोला है बच्चे ने, करेक्ट. ठीक है, सो ए का तो हुआ 2, बिल्कुल करेक्ट. बी का हो गया 4. एक्सप्लेन कर देते हैं. सो फॉर सी, देखो ध्यान, 1.5 मोल ऑफ सी ए फ्रॉम CaCl2. सो दिस है, तो कितना चार्ज का रिक्वायरमेंट होता है? दैट इज प्लस 2, राइट? दैट इज प्लस 2, बिकॉज हेयर वी हैव Ca is in plus 2 state, right? So plus 2. It means we can say that 1 mole of CaCl2 will produce 2 F charge, right? 1 mole कितना produce कर रहा है? 2 mole charge. So here they are asking 1.5 mole of calcium from CaCl2. So how many they required, beta? That is 3F. So obviously option A is absolutely correct. That is A का second सही है, B का fourth सही है, C का 1 and D का 3. So this is absolutely correct answer. Right? Clear है सबको? चलो. Now, the next question is also on the Faraday law, right? So they are asking mass in gram of copper deposited by passing 9.6487 ampere current through a voltmeter containing copper sulfate solution for the 100 second. So what is given, beta? First of all, current is given. I कितना given है? That is 9.6487. Now time is also given. Time is 100 second, and copper sulfate is given, right? Copper sulfate. Molar mass of copper is also given. Molar mass of copper is also given, that is 63. gram, right? So we need to calculate the mass of gram of copper deposited. We know the formula from the first law of the Faraday laws, that is W equal to Z into I into T. And we already talked about this. How to calculate Z, that is molecular mass divided by NF. And this is I and this is T. Just put the value. So molecular mass of copper here is 33. Right. What is N here, beta? So basically in this copper sulfate. So copper having plus 2 charge. Right. Copper having plus 2 charge. So N is 2. What is F here? So this comes out to be 96,487. Now again, I is already given. That is 9, right? And time. So time is 100. ये 2 रहा. This is 96487. ऊपर भी 964812340. 1 2 3 and 40. And ऊपर पूरा वैल्यू कैंसिल हो गया. So the answer comes out to be 60 से डिवाइड करो. क्या आंसर आएगा बताओ फटाफट. फास्ट एवरीवन, कैलकुलेट. फाइंड आउट करो. 63 divided by 200 कितना आएगा. That is 63 divided by 200. Values comes out to be 0.315 gram. So option B is absolutely correct. That is 0.315 gram. Is this clear to everyone? किस तरीके से सॉल्व हुआ. पूरा का पूरा बेस था ओनली फैराडे लॉस पे. जल्दी से कंफर्म करो एवरीवन, ये क्लियर हुआ कि नहीं आप लोगों को. डन. कैन यू मूव अहेड. सर नॉट अंडरस्टूड. बेटा क्या समझ नहीं आया, कैन यू प्लीज एक्सप्लेन. देखो, इन दिस क्वेश्चन वी जस्ट नीड टू कैलकुलेट W, राइट. लेट मी एक्सप्लेन अगेन. In this question, we need to calculate mass, that is W. We already know the formula from the Faraday laws, that is W is equal to Z into I into T. Right? This is the first law of Faraday. ठीक है. तो पहला लॉ था Faraday का, जिससे हम लोगों को ऑलरेडी फॉर्मूला पता है. Now the next thing is we just put the values, because in this question the value of I is already given, value of T is already given, and the copper sulfate solution is given, right? So for W calculation, calculating W, we need Z, I, and T. Now, what is the formula for calculating Z? So Z is calculated by using the formula molecular mass divided by NF. So the molecular mass is copper is already given, that is 63. So we put the value 63. And how we'll take N is equal to 2? Because this is copper sulfate. So on from copper sulfate solution, we get copper plus 2 and sulfate minus 2. So the charge is 2. So number of electron transfer here is 2. The value of N comes out to be 2. Now, value is already given 96487. Just put the value. Now I given and T given. बस उसके बाद just we solve this. इसको solve कर दिया है. That is 96487 से 96487 cancel. 10,000 नीचे आया. 20 से 20 get cancelled. So 63 divided by 200 comes out to be 0.315 gram. Now you got this. अब समझ आया सबको. This is the standard formula for calculating W from the Faraday first law. Yeah, quickly. Response बेचा फटाफट. Yes sir. Okay, okay बेटा. चलो. Now move ahead. The correct value of the cell potential in volt for the reaction that occurs when the following two half cells are connected. Right. The correct value of the cell potential in volt for the reaction that occurs when the following two half cells are connected. Right. So we need to calculate the cell potential, that is EMF of the cell. It's a very simple question. Can anyone tell me the answer for this? बहुत simple है. We just need to calculate the EMF of the cell, nothing else. So we know now EMF of the cell, how we calculate the EMF of the cell. With EMF of the cell, just in the formula E cathode minus E anode, right? EMF of the cathode minus EMF of the anode. Now, a big question arises. How will identify which is plus 1.33 volt? So out of these two values, which one is cathode and which one is anode? So always remember the value which is more, right? Value which is more in magnitude is a minus 2 and we have a plus. So obviously plus 3 is more. We have a minus 5 and we have a plus 2. Obviously plus 2 is more, right? So the value which is होगी उसको हमेशा क्या लेना है? Cathode, and the other value consider as anode. So here the EMF of the cathode will consider 1.33. So this is 1.33 minus 0.44. So value comes out to be 1.33 plus 0.44. So values कितना आया? 1. Option A, right? So 1.437. बिल्कुल सही बेटा. 1.77 volt. So option A is absolutely correct. Now move to the next question. This question is from the conductivity, conductance, all this topic. So the question is the conductivity of the centimolar solution, right? The conductivity of the centimolar solution. So what do you mean by this term centimolar solution? Can anyone explain? Centimolar solution, millimolar solution, डेसीमोलर सॉल्यूशन, क्या होता है ये? सो सेंटीमोलर सॉल्यूशन मींस हो गया 1/100 m. So m comes out to be, their concentration is given 0.1 m. So instead of giving 0.001 m solution, they are giving centimolar solution. So always remember centimolar solution means 1/100 molar solution, right? Now so the conductivity of the centimolar solution at 25 degrees Celsius is given. So conductivity means K is given. It's equal to 0.0210 and the unit is already given, ohm inverse, centimeter inverse. And the resistance of the cell containing solution at 25 degrees R R is also given, that is 60 by A. So value of L by A is known as cell constant, right? Cell constant. Okay, JNV Sabarkanta say option B. Okay, let me check beta. First of all, let's see the solution. So we know that, how will you calculate? We know that K is equal to G into G star. We already derived the formula earlier, right? अभी अभी derive किया था थोड़ी देर पहले. G into G star. Conductivity is given 0.0210 and here G means what? 1 upon R, right? So 1 upon R is 60 and this is G star. This is G star. So G star comes out to be 60 into 0.0210. So this is the value of G star. कैलकुलेट करो एक बार जल्दी से. दैट इज 60 into 0.0210. Value comes out to be 1.26 centimeter inverse. 1.26 centimeter inverse. So this is well absolutely correct. तो जिन बच्चों ने भी बोला था ऑप्शन बी, दे आर करेक्ट, राइट. सो थैंक यू एवरीवन. फटाफट आपने सही सही आंसर निकाला सभी बच्चों ने. ऑलमोस्ट सबने सही आंसर निकाला था. सो इट्स अ ग्रेट थिंग, राइट. ऑप्शन बी इज एब्सोल्युटली करेक्ट. चलो, move to the next question. So the next question is, given below are the two statements. One is labeled as assertion and other is labeled as reason. So assertion क्या given है? In equation delta z is equal to minus nf e naught cell, the value of g depends on n. They are saying the values जो होता है g का वो depend करता है n पे. Reason, e cell is an intensive property and delta g is an extensive property. ठीक है. तो अगर कोई इक्वेशन है डेल्टा जी इज इक्वल टू एन एफ ई, सो n क्या है? दैट इज मोल. सो मोल पे if some properties depend upon mole, then obviously this property is extensive in nature, because extensive properties are what? The property which depend upon the number of moles or mass, they are called extensive properties. So delta g is an extensive property. This statement is absolutely correct. Now E cell is an intensive property because EMF of the cell doesn't depend upon the mass. So we can say that both assertion and reason are absolutely correct, and reason is the correct explanation of assertion. So which option is correct, beta? Tell me first, which option is correct then? Yeah, ऑप्शन ए. नो बेटा, इन ऑप्शन ए, लिसन केयरफुली ना. ऑप्शन ए क्या लिखा हुआ है ध्यान से देखो. बोथ ए एंड आर ट्रू बट आर इज नॉट द करेक्ट एक्सप्लेनेशन. Here R is the correct explanation. Yes, better. D. That is both A and R are true and R is the correct explanation of A. So always थोड़ा पढ़ लेना एक बार ऑप्शंस में आपको क्या गिवन है, राइट. अदरवाइज इस तरह का कुछ एरर भी हो सकता है, बिकॉज मोस्टली ऑप्शन ए इज लाइक बोथ ए एंड आर इज ट्रू एंड आर इज द करेक्ट एक्सप्लेनेशन ऑफ ए मोस्टली. But in some cases they also give option like this. So be careful. Always read the options. Right? Chalo. Now, so the two half cell reactions are given below. NEET 2022 का question है ये. So the two half cells reactions are given below. The standard EMF of the cell with the feasible redox reaction they are asking. So again they want to calculate the E cell. Hmm. E cell. E cell comes out to be E cathode minus E anode. Which is cathode? Which one act as a cathode? Aluminium or cobalt? Which one act as a cathode, beta? Tell me fast. Which one act as a cathode? Those having a higher value. Good. That is, they are saying option D is correct. Okay. Let me check this option is correct or not. So cathode here is aluminium, right? Because their value is more. 1.66. 1.66. Great. This is 1.66 minus 1.81. So value become 1.66 plus 1.81. So value comes out to be कितना आया है जल्दी बोलो. The values comes out to be 3.47 volt. So which option is correct? That is D. So I hope everyone, yeah. JNV, D. एक बच्चे ने बोला था A. A is not the correct answer, बेटा. Negative won't be coming because always remember, for the feasibility of the reaction, for any feasible reaction, right? For any feasible reaction, the value is always comes out to be positive. Value हमेशा क्या आएगा? Positive ही आएगा, कभी negative नहीं आ सकता. क्लियर हो गया सबको ये? डन. चलो, so 3.47 is the correct answer. Now move to the next question. That is the standard electrode potential for the cell with the cell reaction is given. Calculate the standard Gibbs energy for the cell reaction. You need to calculate delta G again. So it's a very simple question. Everyone, फटाफट calculate करो. Delta G is equal to minus NF into E naught cell. फटाफट calculate करो. Everyone, सभी की सभी all values are already given. So just calculate as fast as you can. फटाफट. सबका responses आना चाहिए. Because already we did such type of questions. Calculate D, C, C. Chalo. Let's quickly see the answer for this question. Here the N is again 2. F is given 96487. E naught cell is also given 1.1 volt. So values comes out to be कितना आएगा वैल्यू इसी को किया है ना सो वैल्यूज कम्स आउट टू बी minus 212.27 kilojoule per mole, right? So option C is absolutely correct. ठीक है so option जो C है वो absolutely correct है, right? So C is absolutely correct. I guess many of you already say only C is the correct. Yeah, सबने C ही बोला था ज्यादातर. आयुष गुप्ता, जीएनवी सबरकंता, जीएनवी कर्नूल, सबने बोला था C. So C is absolutely correct, right? So this is a very very interesting chapter as we can see that mostly numericals are directly from formula based numerical just from the few topics like electrochemistry. In electrochemistry basically Nernst equation we have a question, Gibbs free energy we have a question, conductance conductivity we have a question, and Faraday laws. So these are some important topics in which majorly we get questions everywhere, right? Let's see the next question. They're asking at 298 Kelvin, the standard electrode potential of copper 2 to copper, Zn2 to Zn, Fe plus 2 to Fe, and Ag plus 2 Ag are given, right? So their values are given. Copper plus 2 to copper values is 0.34 volt. Again, Zn, their reduction potential values are given. Zn plus 2 Zn value is minus 0.76 volt. Again, Fe plus 2 to Fe values are given minus 0.44 volt. And the next is Ag plus 2 Ag values are given 0.80 volt. Right. Now, ध्यान से समझो अब ऑन द बेसिस ऑफ द स्टैंडर्ड इलेक्ट्रोड पोटेंशियल प्रिडिक्ट विच ऑफ द फॉलोइंग रिएक्शन कैन नॉट अकर आपको बताना है विच ऑफ द फॉलोइंग रिएक्शन कैन नॉट अकर जस्ट टेल मी राइट बताओ फटाफट yes beta this class is also recording in the YouTube account right so you can access this classes from YouTube as well right so no worries okay so on the basis of standard potential predict which of the following reaction cannot occur. Channel name beta Avanti Live 6, right? Avanti Live 6, where in the enable playlist you'll get all this recording. Okay, Avanti Live 6. Okay, so on the basis of this, which of the following reaction cannot occur? Can copper displace Ag? Can copper displace Ag? Anyone? No. Why? Because the value of copper is 0.34 volt and the value of Ag is 0.80 volt. Right. So Ag copper cannot displace Ag. So this reaction one takes place, that is option D, right? Because if you calculate the E naught cell also now, you'll get the negative E naught cell. So we can say that copper can displace Zn, copper sulfate plus zinc. So Zn can displace copper, obviously, because zinc having more negative value. Fe can displace copper, obviously, because Fe having the more negative values than copper. Similarly, zinc also can displace Fe because Zn having the more negative value than F. But Ag can't displace copper because Ag have a value more positive than copper. So it can't displace copper. So option D won't takes place. ठीक है, ये हमारा नहीं होगा। क्लियर है? चलो, so this is again important question. The number of correct statement from the following: conductivity is always decrease with the decrease in concentration for both strong and weak electrolyte. The number of ion per unit volume that carry current in the solution increase on dilution. Molar conductivity increase with decrease in concentration, and the variation of molar conductivity is different for strong and weak electrolyte. And for weak electrolyte, the change in molar conductivity with dilution is due to the decrease in degree of dissociation. So you have to select the number of correct statement out of this. कितने इसमें से correct statement हैं? फटाफट बताओ। फर्स्ट, बेटा यू हैव टू सिलेक्ट द नंबर ऑफ करेक्ट स्टेटमेंट, राइट? नॉट ए बी सी डी। बताना है कि एक सही है, दो सही है, तीन सही है, चार सही है। सो द फर्स्ट ऑप्शन इज like the A, that is the conductivity always decrease with decrease in the concentration. Conductive solution is decrease in the concentration of both strong and weak electrolyte. बताओ क्या होगा ये? सो एक चीज याद रखो, ऑन डाइल्यूशन, जब भी डाइल्यूशन करते हो तो एवरीथिंग दैट इज, चाहे वो मोलर कंडक्टिविटी हो, इक्विवेलेंट कंडक्टिविटी हो, ऑल वैल्यूज आर इंक्रीज एक्सेप्ट कंडक्टिविटी। कंडक्टिविटी की वैल्यू डिक्रीज होती है, ठीक है? और जो वीक इलेक्ट्रोलाइट्स है, वीक इलेक्ट्रोलाइट्स ऑन डाइल्यूशन उनका डिसोसिएशन होता है एंड देयर कंडक्टिविटी इंक्रीजेस। सो दिस क्वेश्चन आई सबको देता हूं मैं एज अ होमवर्क, ताकि तुम लोग इसको एक बार जस्ट रीड आउट करो कि कौन कौन से स्टेटमेंट करेक्ट है। तो दिस क्वेश्चन सबके लिए एक होमवर्क की तरह है, और एवरीवन ट्राई टू सॉल्व दिस क्वेश्चन एंड यू हैव टू आइडेंटिफाई हाउ मेनी स्टेटमेंट्स आर करेक्ट, राइट? आउट ऑफ दिस 1 2 3 4 5 स्टेटमेंट, यू नीड टू आइडेंटिफाई हाउ मेनी स्टेटमेंट्स आर करेक्ट, कौन कौन से स्टेटमेंट यहाँ पे करेक्ट है, ठीक है? ऑलवेज रिमेंबर, डाइल्यूशन पे मोलर कंडक्टिविटी, इक्विवेलेंट कंडक्टिविटी, कंडक्टेंस सब इंक्रीज होता है, all increases except conductivity, because on dilution number of ions is decreases in 1 ml, so conductivity is also decreases, right? So I hope this is clear. Now I am going to launch a poll. सभी लोग इसका क्विकली रिस्पॉन्सेस करना, ठीक है? चलो, क्विकली रिप्लाई, सभी लोग रिस्पॉन्सेस दो। आई ऑलरेडी लॉन्च अ पोल, सभी लोग इसके रिस्पॉन्सेस दो बेटा। फास्ट, फास्ट फास्ट एवरीवन, यू हैव 2 3 minutes ओनली। सो थैंक यू ऑल, मिलते हैं नेक्स्ट क्लास में. देन वी आर गोइंग टू सी सम अनदर चैप्टर्स एंड एमसीक्यू. टिल जस्ट try to solve the questions related to this chapter, right? Because this chapter is very very important for the examination point of view. So just try to solve the questions as much as you can. And this is totally numerical based chapter. Some theoretical questions also came, but mostly only numericals were come from this chapter. So thank you all. Next class में मिलते हैं. Then we are going to see some important questions as well.